testing the transaxle range sensor, and I've already gone ahead and diagrammed all of the different spots on it: park, reverse, neutral, drive, 2, and then 1. And this D right here that points over here, that means absolutely nothing. Pay no attention to that D. All of your marks are going to be on the left side over here, where this hash is going straight across. What I did was went to pmx626.info and I printed out this diagram. This diagram will tell you all of the pins on the transaxle range sensor. It's not going to tell you how to test them. That's on a different one, but this is page K2157 of the 1994 workshop manual. So what we're going to be doing is showing you all of the different switches. So we'll start over here in park. Park is actually a fairly easy one. You go from your joint box connector, the top leftmost pin, to the bottom rightmost pin, which is park, and you should have continuity between those pins. So we got continuity. We have continuity because this is switched to park, so you will get continuity on the joint box and the park pin. Now if I were to switch this over to, let's say, reverse, then you would get continuity on the joint box and the reverse pin, and so on and so forth. You can test for continuity between all of your different switches and make sure that all your switches work as far as your gears. That's the only thing that you can test on here is the gears. The start circuit will always be open. You will always be able to get continuity on the start circuit as long as you are either in neutral or park. Let's just say that. This is part of your safety feature. So how does one take a mechanical switch and transfer that into an electrical switch? Because I'm still using the automatic ECU, the car always has to be in park in order to drive. And that's just how it has to be with the manual transmission and the automatic ECU. So how does one switch from park to reverse in order to turn on the reverse backup lights? Because the switch, or the circuit for the reverse backup light switch on the transaxle range sensor will not open unless this switch is mechanically twisted to the reverse position. I'm going to have to come up with my own switch because this is a mechanical switch, but I want to do this electrically or electronically. You can't do anything with that in the manual transmission. There is no shift cable in the manual transmission. The easiest way would just be to modify it electrically using some kind of switch circuit or relay. So that's what my plan is to try and figure out a way to turn park and reverse here into a relay, because I thought this was all going to be electronically controlled. I thought, you know, you put so much resistance on one pin and it would open up the gear, and all of these would have continuity anyway. It would just be different resistance values. That would be so much easier to work with. Okay, I just ran up to the parts store, got a relay. It's a Bosch relay, triggered relay, one that I need. That's the part number from Advanced Auto. And now we are ready to start testing. This relay is going to be the end result if all of my tests check out and work like I think it's supposed to. Okay, here's the diagram from the 4th gen workshop manual. This is the correct diagram. If you notice in the 95 body electrical troubleshooting manual that this diagram has 9 pins, that is a discrepancy that I found, and it is wrong. This is the correct one. This is K2157 of the 94 workshop manual, and the 95 workshop manual has the same exact diagram, and they are correct, except the only difference in the 95 manual is that this is labeled as 1, S is labeled as 2. I don't know what L and S are. Those might be misprints, but it's 1 and 2. Okay, so I've taken a page out of Scanner Danner's book, and I went and found some T-pins at a craft store. I also found these alligator clips at Advance. Got some wire from Advance. In total, it took about $10 to wire up my own alligator clips. About 5 for the wire and 5 for the clips. The clips come in a set, 2 red, 2 black, all in one box. And they're solderless, which I really like. So I didn't have to mess with my soldering gun or soldering iron. All I had to do was crimp these. So that's really neat, really quick. And now I have legitimate Scanner Danner setup. Well, minus the $10,000 lab scope. Multimeter should work for this because I'm just measuring voltage. I don't need to see a waveform signal or anything like that. All of my pins do exactly match this 94/95 diagram. Alright, on the sensor signal circuit, check for continuity. while the circuit is energized. There was no continuity when the circuit was not energized. Now we're getting continuity. So that circuit's good, and that's always there. That's always present. So that's going to be your reference voltage. It should be 5 volts. My guess is that's going to be a 5 volt reference signal. So it's either going to be 0.2 or 0.02. One of those. 5 volts? 40. Alright, so what is 0.02? Because if that's a 200 scale, it might be off. 4? 4 volts. That sounds much better. 4 volt signal. 4 volt reference signal. Probably varying between 4 and 5 volts. That's your reference. Now every time I want to test this thing, I have to make sure that the car cools down for a long time because it's right next to the header and right next to the upper radiator hose, so it's really hot in this area. So it's going to take me a while. Okay, disclaimer time. I am not a technician. I don't know what I'm doing. Okay, I know somewhat what I'm doing. So there's a very real possibility that if you go to attempt this kind of diagnostics that you're going to short out either your transaxle range sensor, blow a room fuse, or something like that. I am the first to document automatic to manual transmission swap using the automatic ignition system. No one's done that to my knowledge. Everyone always just goes with the manual transmission ECU and harness, and of course that's a lot easier, but as I've demonstrated, not completely necessary. However, you have to be prepared to do a little bit of wiring work. So with that said, let's continue. What I have discovered is that you don't have to complete the circuit. The circuit's already completed there. What you have to do is take the other half of your lead, pass this through the multimeter. The other half of your lead will go to ground. So I've been using the hood latch lever to go to ground, and that'll get you a signal. But that signal is only present when the car is running. So there's no signal going through there when the car is off. And because of the proximity to the header, really hot, I don't really want to touch that until that's cooled down. So I'm taking about 5-minute cool down periods in between swapping out the pins to check different locations. This is all just me learning. This isn't really going to be a good diagnostic video or a good instructional video. This is just me poking and prodding, and I guess sometimes that's part of the diagnostic process, is that you have to back probe, you have to poke and prod, and you have to figure out how the circuit works so that when you do go to modify it, you don't completely screw up your system, blow up your PCM. Well, it's not going to blow up, but it'll short out and then your car won't start or something like that. And the reason you want to measure your battery voltage is because some sensors do use, a lot of sensors actually use battery plus voltage. And in the wiring diagrams you'll just see B plus. And that B plus is going to be whatever your positive charge is. So in my case it's 13.47 or thereabout. I mean, it'll fluctuate a little bit as the alternator is running. If we're going to get battery voltage signal on these pins while the circuit is closed, which means that the car is running in park, and I measure the park pin and the joint box pin, both of those should give me battery voltage. So the red lead is park and my black lead is the joint box. We're going to measure that first. The park pin is getting battery plus voltage, varying 12 to 13. So now I want to swap that pin onto the reverse and then put the car in reverse and see if I get battery voltage on that pin. Well, I accidentally forgot to record, but whatever. Started, put it in park, switch it to reverse, got a signal, got a negative battery voltage signal. Negative. I don't know how that happens. But that's reverse. Negative battery. Maybe it's because I'm shorting at the ground. That could be. Okay, so everything works on battery voltage. The reference signal is only for the test pins. The reference voltage is also so that the PCM will see that the transaxle range sensor is working. So it routes a signal through it, and if 5 volts go in and 5 volts go out, and it comes back and it says, I see your 5 volts, that means the transaxle range sensor is working as far as the PCM is concerned, and then it will start switching and doing all the other stuff. But it's just a dumb switch, meaning there's no relay involved. It's just a switch based on mechanical position, which uses battery voltage. So with that in mind, we can introduce a 12 volt relay and relay the backup switch into that loop using jumper pins. Just by using jumper pins in one relay, I'm hoping to take this entire switch out of the loop. For a manual transmission, you don't need anything but park and reverse. There isn't any other output signal that the transmission gives you to let you know which gear it's in other than park and reverse as far as the manual transmission is concerned, or neutral and reverse. Use the backup light switch as the trigger, using a Bosch regular 87A switched relay. So that's 87 is always on unless 87A is on using a trigger, and the trigger is going to be the backup light switch. There's the backup light switch connector, the little white one down there. And there's the backup light switch on the transmission. And that is going to get power through the firewall to the room fuse. So what I'm going to do, just for testing purposes, I'll make it all nice and clean later, but just for testing purposes, I'm going to put this wire back here, and then I'm going to go ahead and wire that directly up to the room fuse itself. Now here is your secondary breakout box here. And you'll be so lucky if you have one of these nice little fuse pullers. Here we go, room fuse 15A. That's going to be on the bottom here. This fuse right here is sticking out a lot more than all of the others. All the others are flush, but this one sticks out because the room fuse powers almost all of your interior lights, a lot of accessories, your dimmer switch, I mean, you name it. The room fuse is a major fuse in your interior. But what you're supposed to do is pull out this entire box and then go at it from the back and wire your whatever wire that you want to wire in from the back. But as you can see, what I do sometimes is I just stick a wire right on the fuse and then jam the fuse back in there. It works, but that's only supposed to be a temporary measure. And a lot of times temporary has a habit of becoming permanent. So don't do that, because that's bad. Now there is a good side and a bad side to this fuse. One side is going to be before the fuse, and one side is going to be after the fuse. And you want to put it after the fuse. But just looking at these, you can't really tell which one is before the fuse and which one is after the fuse. Unless you provide it power, and we're not going to do all that crap just for testing purposes. Now I'm going to go with before on the bottom and after on the top, just as a guess. So I'm going to bring it in from the top. Now as old as this thing is, or looks, this thing works amazing. This thing is awesome. And it has sides for different holes. Now you can see how this one works. That's how it works. It's pretty neat. Easy. You just wrap the ends around one of these plugs. But wrap it like so. And then shove it in there. This is just for testing. Alright, so we take the wire from the room fuse, route that all the way down. That is going to get connected to the backup light switch. This end is connected to backup light switch. The other end that comes out is then going to be your trigger for your relay. So this power from the room fuse is going to trigger the relay. We've got T-pins set up here, and I'm going to use my alligator clips on the T-pins just to test this relay, test this circuit, just to see if it works, and then I will go back and figure out a way to hardwire it up and clean it up and make everything nice and neat and put it in a harness and a loom and all that good stuff. Here's the relay I'm using. The pins are labeled as well. Now I've wired up this spade connector, which is the same size as the male spades here. This is a female spade connector and that's a male spade. So this is going to go right on here. So I'm just going to use these individually, acting as two wires, and there's alligator clips on both ends. So that's going to work. And that's why I have the T-pins in there. But then I realized I need 3 sets of alligator clips for that, and I don't have enough. So I'm just going to use a spade connector and some wiring. Basically, I'm just rigging this up any which way I can. I had to smush the wires into the sockets. I guess I didn't really need to do all this alligator clip T-pin junk anyway, because well, I did, because you have to put 2 wires into one socket, which is what the T-pins accomplish. For the joint box, you have to put 2 wires in the joint box, 1 wire in reverse, and then the other wire on park. The key in this ignition, let's say. No key in. Neutral. No backup light switch on. Put the car in reverse. The car turns itself on without the key in the ignition. The reverse lights do not come on. Put the key in the ignition. And we're going to go to ACC 1, accessory position 1. I'll turn on the accessories. No lights on the dash. Put it in reverse. No backup light switch. Actually, it's not backup light switch, it's backup light. Position 2, on. Both lights come on. No backup light. Put it in reverse. No backup light. Okay, so the circuit doesn't work. Alright, I think I figured out my problem. I need a diode. I am getting feedback from this line, and I could measure that and I could test that, but I think it's fairly obvious from the way this circuit is built that I'm going to get feedback all the way back to the relay. I need a diode. A 50-cent diode would do. Unfortunately, I live a half an hour away from the closest Radio Shack, and that's going to have to wait until tomorrow. Alright, here we are the next day. I ran up to Radio Shack. I got some diodes, epoxy rectifier diodes, and I accidentally grabbed the wrong diodes. I hope these are going to work, because it's a half an hour drive just to Radio Shack. As you can see in the joint box pin, I have my T-pin going in there, as well as a wire crunched in there. So basically I have two wires occupying the same slot. And when the circuit is energized, and this green one, if you remember, is the reverse pin. So this is the joint box pin. So let's say that I have my reverse circuit energized. The electricity will flow down this wire into that pin, but then it will also flow up the blue wire and back to the relay, and we don't want that. So what a diode does is it stops the flow of electricity going back. It's like a check valve. It won't let it go past the diode, which is what we want, because we don't want it feeding back to the relay, because then that energizes this other blue line. It will also energize this one and turn on park at the same time, completely defeating the entire purpose of the relay. That's all a diode does. It's a check valve, basically. So we're gonna have to strip these leads off and wire in our diodes, and I'm going to use some alligator clips just to test this circuit. All of this wiring junk is just a test circuit. I'll clean it up later. Okay, now I have my diodes. The silver cap on the diode points in the direction that you don't want flow to go. So we don't want flow to go back this way, so you point your cap in that direction. And that's pretty much all there is to it. I mean, it's as simple as that. You just wire it in. And I have alligator clips holding mine, and that's making good contact. So just make sure that you don't have any shorts, make sure that all of your pins aren't touching anywhere, no metal to metal contact. See, this is actually pretty close to the radiator there, so I'm going to want to kind of set this there, something like that, out of the way, not getting close to any metal. I'm using speaker wire, but you never want to use speaker wire as a permanent solution in your engine bay, because speaker wire insulation will melt. Insulation for automotive wires is a different kind of insulation than for speaker wire. It's okay to use this on the interior of your car, but never in the engine bay or anywhere that has a high heat application, because it will melt this insulation off. It's just clear plastic, whereas this is more hard, thicker silicone. So don't use speaker wire in your engine bay, okay? But for this test, it's absolutely fine. Oh yeah, make sure none of the pins in here are touching. I think we're ready to go. Ready for test number 2 of DJ Devon 3's bad circuit design. Take 2. And since this is a learning process for me as well, I'm taking you on my adventure. Still gonna go back here and check my tail light. Nope, it's not lit. So we're gonna put that in reverse, make sure your e-brake's up. Nope, still not. Now it does. Okay, it just came on. Like most of my projects, I learned the hard way. I overcomplicated this design. You don't need any diodes. You don't even need 3 wires. You just need 2. This has been a very long learning process for me, and we're talking 3 or 4 hours at a time between troubleshooting and allowing the headers to cool, because I was trying to do it while the car was running, which was unnecessary. You can do this while the car is off. Let me show you the finished product. We have 2 wires. For all intents and purposes, these could both be T-pins or could both be wires in here. I just have it rigged up this way because this is a temporary solution. As you see, we have 1 wire going into the reverse light pin and 1 wire going into the park switch. I was under the assumption that this circuit worked on continuity, so you would need 2 wires jumpered between both circuits in order for it to work, and that's untrue. And I know it doesn't work on resistance because all of the resistance values are the same, so that only leaves one thing, and that is voltage. This circuit works on voltage, specifically battery voltage. It's not directly from the battery though, it is from the fuse box. It just has 1 wire going into the reverse pin, 1 wire going into the park pin, and I have it hooked up to my relay. I ran another power wire, and this one goes to the meter. This one goes to the meter because the meter is your instrument cluster, and that is only turned on when the car is on. I only wanted this circuit energized when you get in the car and you put the key in and turn it to the on position. That's the only time that this fuse gets power. So why did I want that? So this wire from the room fuse is acting as my relay power. This is the constant power pin for the relay. So that only gets energized when the meter fuse is on. And that means the key in the on position, at least the on position, if not start. Pin 30 is coming from the meter fuse, and pin 85 is your battery ground. Pin 86, which is this black lead, goes down to the switch. And polarity does not matter on the switch, so you could have one positive on the right, negative on the left, or positive on the left and negative on the right. It doesn't matter. It's just a switch. It just needs to complete a circuit. And then my other green lead from the switch wraps around here and goes back down here. This green wire gets powered by the room fuse. It's a 15 amp fuse. The room fuse is powered all the time. So this would be the same thing as me hooking it up straight to the battery, except you're supposed to have an inline fuse on both of these circuits. Both of these wires should have fuses on them. So instead of wiring in an inline fuse, I've just chosen to use the existing fuses in the box. And now that this circuit is working and complete and I've tested it, these two wires will get moved and plugged into the back of each respective fuse. And that's just to make for a clean install. 87 is this blue wire on the top, and that goes to your reverse pin. The park signal is going to get put on 87A because 87A is the always on. If this is powered, this is always on until it is triggered by your backup light switch, and then this circuit gets powered, which is your reverse light switch. Here's my jumper wire. It is much easier if you use solid core wire instead of braided or stranded wire. One, it'll go in a lot easier and you won't be missing any of the excess threads that are just hanging outside. So we got second pin on the top, third pin on the bottom. Alright, and there's your start circuit. Really simple. Then you have to do the same thing for the transaxle range sensor signals, return, and feed. And that's going to be this top left pin and the second on the bottom, and just do the same thing, just put a jumper between there. And if you ask me what this does, I'd probably say it's your reference voltage. It's probably going to be a 4 to 5 volt reference voltage signal that tests the transaxle range sensor. Now without this pin, it's going to set a code. It's going to set a no signal to the transaxle range sensor code. Now the importance of this circuit is to let you know, or more specifically let the computer know, that there's a problem with this circuit. If this circuit does not have continuity at any time, it's going to set a code. And there you have it. That's all there is to it. And this is the final product. This is what your circuit should look like. No soldering, a little bit of wiring. I mean, you can even mush these wires down in there if you want. You don't have to have any kind of connector. I went for these crimp-on end spade connectors, female spade connectors, which worked out really great. About $3 from any local auto parts store. That makes that install so much easier. But on this side, you're going to have male pins. So I recommend that you get solid core wire so that it's a lot easier to push in than braided wire. As you can see here, this braided wire, this blue one, is smushed in there. And that's not good. You want full connectivity in there. So get yourself some solid core. Now that you have your reference voltage circuit and your start circuit, we can go ahead and start the car, test the car, and put it through the gears, put it through the paces, make sure that park and reverse both work. Oh, and I didn't even need this other jumper with the other diode on it. Didn't even need it. Okay, we have park. And reverse. Alright, so let's leave it in park. Backup light is not illuminated during park. Alright, we're in reverse. I think the wiring in here is going back. We can see the reverse light is on. Yep. Alright, now let's put it in reverse. Check reverse. And as you can see, we have the backup light on. Neat. Reverse is a little dim there, and my only guess is because I need to replace some of these bulbs. Every time I put my car in reverse, my radio goes off. Alright, now I'm going to go in reverse. It just goes off. Oh. Damn. I had a blinking airbag light too. Ah, Jesus. Man, it's not one thing, it's another. I ran my battery out doing all this diagnostic work, probably a couple hours, and the battery voltage dipped down to about 10.45, and that's just low enough to not engage the starter, so we can't do a start test. Anything below 10.5 volts and your starter's not going to crank over. It's just going to turn the solenoid on, but it's not going to engage the motor. So you'll hear a click, but no start. So if you have a no start, check your battery voltage, because if it's below 10.5, and normal battery voltage is anywhere between 12 to 14 volts. Alright, now that we got the battery charged up, let's try this again. Turned it on. My accessories are coming on now. Alright, got park. Got reverse. Crappy start, but whatever. But it's a start. The starter circuit is engaged now, so we're looking good. And that's all there is to it. I've already shown you both pins on the Transaxle Range Switch connector plug side and on the relay side. I did switch one of the wiring though. This is the power wire for pin 30 on the relay. I went into the radio fuse, which is the second one up, and that worked. As you saw before, it was shutting off on this one. It was shutting my radio off on that one, so yeah, don't do that. So that's the ticket. It works. So that's all there is to it. I am now road legal. I can drive this at night now, forwards and backwards. Haha. Now if you've been wondering how I'm going to make this airtight, because this is hanging down in the engine bay, I'm going to actually come up with a custom connector for this. Eventually I'm going to cut off the wires from this plug and eliminate this plug completely, because there's no other end of this plug. So I need to find a suitable watertight plug, and I was thinking about making a box for the relay and the plug. Here's my project box that I got from Radio Shack. Just real simple. Unfortunately, the relay is just a tad too big. The pins will stick out, and I can't angle it. Oh, I might be able to angle it that way. That's going to be close. That's going to be real close. Shove this relay in here and do a whole entire harness connector on here, and then have a harness sticking out this box, so that if I want to unplug my entire thing, I can, just to get it out of the circuit for like an emergency pull or something, just in case this circuit fries for whatever reason, or the relay fries. That's a good thing to have. It would probably be a good idea to add a diode on each line here as well, just so that you prevent feedback. However, on this circuit that shouldn't happen, but you know, that's what diodes are for, just in case kind of thing. So I'm gonna call this project done. Pain in the butt, but got it done. Cool.